Welcome to Two Projects. In this video, we are going to explain the project ImageNet classification and detection using deep learning. Before diving into the execution, let me give you an overview of the project. So, the project uses deep learning methods to tackle challenges in image classification and object detection, particularly with the complexities found in real world images. So, these complexities include variations in lighting, perspectives, occlusions, and different backgrounds, making them difficult for traditional algorithms to handle accurately. So, to address this problem, the project leverages deep learning techniques to enable models learn complex patterns directly from the data. To ensure robustness, the project utilizes ImageNet 21K dataset and additional data from RoboFlow, enhancing diversity of the training data. And image processing is very important, involving pre-processing steps for classification tasks like resizing and augmentation, and torch vision based techniques for object detection, ensuring models can generalize well to various conditions and situations. After image processing, variety of architectures are implemented including exception, densenet, and transformer CNN, that is VIT, for image classification, and variants of YOLO, that is YOLO V5S and YOLO V5X6 for object detection. So these are known for their efficiency and effectiveness. So after training these models, we will test the models using different performance metrics to select the best performing model among all the models built for classification and detection. So post training, user authentication via Flask integrated with a SQLite database ensures secure access to the system. So users can conveniently upload images through a user-friendly interface for analysis. So these images undergo pre-processing before being fed into the trained models for prediction. The project serves researchers, developers, and practitioners in computer vision, offering a robust framework for image analysis tasks with applications across various industries like healthcare, automotive, and security, where accurate image classification and object detection are very important for decision making processes. So, this is what we'll be doing in this project. Now, we'll look at the software and hardware requirements. So, hardware requirements to execute this project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database used is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So these are the algorithms built for classification task, and these are the algorithms built for detection task. So we have trained all these models. We have compared the models. So we have compared these classification models using accuracy, precision, recall, and F1 scores. And we have compared detection models using MAP, precision, and recall. And we have selected the best performing model among them for classification and detection tasks. So exception model has outperformed DenseNet and Transformer CNN models. And in detection, YOLO V5X6 has outperformed YOLO V5S. So we have deployed these two models, exception and YOLO V5X6, into the Flask web application for respective tasks. So now we'll look at the execution. We'll be executing the project using Flask web framework. So before execution, first we need to. So this is the code folder and these are the contents I have in the code folder. This is ImageNet 1000 dataset folder in which I have required dataset. I have 10 different classes of folders here: Bald, Eagle, Brambling, peacock, goldfish, etc. So I have respective images in these folders. In bald eagle folder, I have bald eagle images. In peacock folder, I have peacock images. Similarly, I have respective images in other folders also. So before training the classification models on these images, we will split these images into two subsets, train and validation sets. So after doing that, we have stored train and validation sets in the train and validation folders in output folder. So now 80% of the images from all the 10 classes are into train set, and 20% of the images from all the 10 classes are into validation sets. Train set is for training the models and validation set is for evaluating the model's performance. And this is sample folder in which I have images again on which will make the classifications and detections. So we'll have the test cases in this folder. This is static folder. So this folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is YOLO folder in which I have dataset to train the YOLO models. So we can see I have images, train and validation folders here. So in images folder, I have images and their label files, associated label files. So we will split the images and label files into train and validation sets. So train set is for training the models and validation set is for evaluating the YOLO model's performance. So in train set, I have images and label folders. So in images folder, these are the images I have. So these are the combined images from all the 10 classes. And in labels folder, I have annotation files. So each annotation file corresponds to an image file in the images folder. This annotation file corresponds to this image in the same way. This annotation file corresponds to this image. Similarly, each annotation file corresponds to an image file in the images folder. So these annotation files often follow YOLO format where each line, this is the line, represents a detected object. So in this image, there is one object detected. So the first column in the line represents the object's class index followed by its bounding box coordinates. These are the bounding box coordinates of the detected object. This is the x limit, this is the y limit, this is the width, and this is the height. So in the same way, I have object's class index followed by its bounding box coordinates normalized to the image dimensions in other label files also. So these label files correspond to an image file in the images folder. So on these images and label files, we'll be training the YOLO models as they are from the train folder. Similarly, I have images and label files in validation folder also. On these images and label files, we'll be evaluating the YOLO model's performance. So this is about the data set. This is app.py file. So this .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is classification Jupyter source file and this is detection Jupyter source file. So Jupyter Notebook allows users to execute code in individual cells, making it a popular choice for data science. So it contains a combination of code, graphs, and outputs all in one place. And this is signup.db file. This file is the database file used to store user information. It stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first. Fill in all these details and click on sign up button to register. If we are already a member, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on sign in button. So it has redirected us to the predictions page. So as I mentioned earlier, we can perform both classification and detection tasks in this project. So click on the prediction link. So first we'll perform the classification task. Click on classification link. So now we have to upload any image here and the application will classify the object from the image. Click on choose file button. From sample folder, from classification folder, as we are performing classification task. So these are the test cases I have. We'll upload the first image, select the image and click on open. The image has been loaded. Now click on upload button. It will take some time to load. So this is the uploaded image and here we can see the result, that is bald eagle. So the application has classified this image, this object as bald eagle. Click on try again. Click on choose file. We'll try with this image. Select the image and click on open. The image has been loaded. Now click on upload button. This is the uploaded image. And here we can see the prediction, that is brambling. The application has detected the object as, classified the object as brambling. Click on try again. We'll try with some more test cases. Click on choose file. We'll try with this one. This is the uploaded image and here we can see the application has correctly classified it as great gray owl. Click on choose file. Select the image. I'm selecting this one. So we can see the application has classified them as ostrich. We can see the correct classifications. Click on try again. Click on choose file. Select the required image. I'm selecting this one. This is the uploaded image and here we can see the classification, that is peacock. Similarly, we can upload any image from the test cases and can get the classifications. We'll try with this one. This is the uploaded image. And here we can see the prediction, that is great white shark. Click on try again. Click on choose file. Select the image. Click on open. The image has been loaded. Now click on upload button. So we can see the application has classified them as goldfish. Click on try again. Select any image. We'll try with this one. This is the uploaded image, and here we can see the correct classification, that is ostrich. So in this way, we have to upload images and get the classifications. Now we'll perform the detection task. Click on prediction link, select detection link. We have to upload images again. Click on choose file. So this time from detection folder, as we are performing detection task. So these are the test cases I have in detection folder. I'm selecting this image and click on open. The image has been loaded. Now click on upload button. It will take some time to load. So this is the uploaded image, and we can see the application has detected the bald eagle. It has drawn a bounding box around the detected object. We can see the label here, bald eagle, and beside the label we can see a confidence score telling us the confidence level of the system in classifying it as bald eagle. We'll try uploading another image. Click on choose file. Select the image. We'll try with this one. Click on upload. This is the uploaded image. We can see the bounding box drawn around the detected object. And here we can see the label, that is bald eagle again. The application has detected and classified the bald eagle. And beside the label, we can see the confidence score telling us the confidence level of the application in classifying it as bald eagle. Click on back. Click on choose file. We'll try with another image. We'll try with this one. We can see the application has detected the brambling bird. It has drawn a bounding box around the detected brambling bird. And here we can see the label. Beside the label, we can see the confidence score, which tells us how confident the system is about this classification. Similarly, we can upload any images from the test cases and can get the detections. We'll try with this one. We can see the application has detected the goldfish. We can see the bounding box drawn. We can see the label, and beside the label, we can see the confidence score. Click on choose file. Select the image from the test cases. This time I'm selecting this one. Click on upload. We can see the application has drawn a bounding box around the detected object. It has classified it as peacock. And beside the label, we can see the confidence score telling us how confident the system is in classifying this object as peacock. Click on back. Click on choose file. We'll try with some more test cases. I'll try with this one. We can see the application has detected the great white shark. Click on back, click on choose file. I'll try with hen this time. I'm uploading this image. We can see the application has detected the hen. It has drawn a bounding box around the detected hen. We can see the label here. Beside the label, we can see the confidence score. So in this way, we have to upload images from the test cases and can get the detections. We'll try with owl. I'm uploading this image. So we can see the application has detected the great gray owl. We can see the bounding box drawn. We can see the label here. Beside the label, we can see the confidence score, telling us the confidence level of the system in classifying it as great gray owl. So now we'll see the classification graphs. So this is loss and accuracy curve graph of exception model. So in this graph on x-axis, I have epochs, and on y-axis for this graph, I have loss, and for this graph on y-axis, I have accuracy. So we can see for every increasing epoch, loss is decreasing, and for every increasing epoch, accuracy is increasing. That means the exception model is doing well. This is accuracy scores comparison graph, a horizontal bar graph. So in this graph on x-axis, I have accuracy scores, and on y-axis, I have algorithm names. These are the algorithms built for classification. So this graph is the precision scores comparison graph. In this graph on x-axis, I have precision scores, and on y-axis, I have algorithm names. Similarly, this is recall scores comparison graph, and this is F1 scores comparison graph. So from all these graphs, we can see that exception model has outperformed the other two models, Transformer CNN and DenseNet. Now we'll look at the detection graphs. This is F1 confidence curve graph. This is precision recall curve graph. This is confusion matrix graph. This is precision scores comparison graph. This is recall scores comparison graph, and this is MAP scores comparison graph. So from these three graphs, we can see that YOLO V5X6 has outperformed the YOLO V5S in all the performance metrics. So these are the graphs. Now click on sign out. So the project employs deep learning techniques to enhance image classification and object detection, addressing the complexities of real-world images. With diverse datasets, efficient pre-processing, and user-friendly interface, it provides a robust framework benefiting various industries' decision-making processes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.